All right, I think we'll go ahead and get started. So my name is Mike Rayleigh. I am PAC's Director of Engineering, and we started doing a series of webinars, usually monthly, although in this case for this series we've been doing it every couple of weeks. But started this webinar series to kind of just help provide more information to folks. As I've come to PAC, I've seen that PAC has a lot of knowledge and expertise in construction, acoustics, and fire. And I wanted to help kind of get more of that knowledge out there for folks. And so that's really what gets us to this presentation. It's a three-part series on sort of the intersection between fire-rated designs and acoustics, and looking at helping understand the fire-rated designs, the UL assemblies, those requirements better, looking into some of those nuances and how those things can affect acoustical performance. So with the idea that hopefully we can all work to get better designs that both meet the fire requirements and the acoustical performance requirements that we're going for. So our first part was just sort of a general overview. The second part was on walls, and this third part will be on ceiling designs. And this was originally intended as a three-part series, so this is our final. Later in a month or two with a follow-up, maybe going over some of the general provisions and addressing some of the questions that have come up in our last webinar about walls. We also had some questions about intersections and how you deal with those, some of the details and things outside of just the basic assembly. So I think we'll come back and touch on those things because there's a lot of ground to cover there. So with all that, we will get started here. This presentation is going to be by Mike Gernhardt, our Vice President, and he's going to go in and talk about ceiling designs. So with that, Mike, go ahead, take it off.
Thanks, Mike. Like Mike stated, today we're going to work on part 3 of a 3-part series. Hopefully, we're in deep discussion now of what the fourth set of this presentation will look like, but I think we'll probably have a fourth one, but it'll be down the road once we further define that. So let's get busy on this and get moving through it. So again, thank you everyone for coming. Today we're going to look at a 1-hour fire-rated open web truss. There's a couple reasons we picked this system. You can see here, there's 2 images on UL. Again, if you were here for the wall session, we went from top to bottom, or from 1 through, I guess, 16 on the wall. This one only has 10 items involved, so that'll be a little shorter, but there's we're going to get in depth into the middle section of this assembly and look at some additional information in there that is important to know, especially from an acoustical standpoint. So you can see in here, it shows the primary assembly with no insulation or insulation pinned to the top, and then it shows an alternate insulation position on this assembly. Why did we choose open web trusses? Well, you can see here a trend that I've seen, or that we've seen over the years, is that open web trusses are a little more flexible when it comes to HVAC, plumbing, and electrical. It allows you to run your equipment in any direction throughout the assembly, where an I-joist or a solid timber may not. In those scenarios, you're probably going to have to build soffits to run some of your ducting or maybe some of your exhaust vent fans, and that can be acoustically not perfect. Also, then it adds into the difficulty for fire stopping and draft stopping into those intersections where the soffit may meet the wall and the ceiling maybe not in the ideal position. So here's the system we're going to look at today, which is ULL 587. It's an open web wood framed truss system. It's a 1-hour system, and it has the ability to add insulation to it. It is also has the option for no insulation. So we'll get into that as we move forward here a little bit. It's like Mike timed out for some reason. So let's get to it. We're going to start at 1 and work our way all the way down, 1 through 10. So item 1 is the floor system. So what that means is the material above the truss. So there's 27 options for the top system. The 2, let's call it minimum options, would be a layer of nominal 3/4 inch structural panel, plywood, OSB, if it's a structural panel, and then a 1/2 inch structural panel or OSB, again, over the top of that. An option 2 for that would be or system 2 is the way it's termed in UL's write up, it would be that same 3/4 inch structural panel, but then with a poured in place material on top, minimum 3/4 inch. And then your 27 variations are going to be types of mat, thicknesses of the poured in place material, maybe an alternate wood type products, or like Homosode or something like that is also listed in this assembly. So there's a lot of options on the top side that can change the acoustical performance or the values that you see within the system. So we're not specialists on that side. We do have a lot of knowledge when it comes to which mats to use, how much of the poured in place material to use, and also what the performance looks like without any of those materials in it. When we do our testing, a lot of times we'll test a bare system first to get some baseline data, and then we'll start building off of that. Item 2 in here is the truss itself. So the truss is maximum spaced at 24 inches on center, minimum depth of 12 inches. So we talked about this before. There are a lot of maximum and minimum references in the UL fire resistive designs. And with that being said, the maximum spacing is 24 inches on center. So you can always space them closer together at 16 on center. That can have some repercussions later down the road, which we'll get to when we start talking about line item 5 and 6 and how those spacings can actually change the total cost and performance of the system. And it says here minimum depth is 12 inch. We typically see an 18 inch open web truss. That's for multifamily. I think that's kind of a sweet spot where it gets you the longest span and allows the builders to use those for their advantage when it comes to spacing and layout. So line 3, I did it again. Item 3 is your air duct. And this, it calls out for any class 0 or class 1 flexible air duct. It doesn't call out for a rigid air duct. We're not HVAC specialists, so I'm sure there are some guidelines in there that says a flexible duct is a minimum, maybe a rigid is an improvement. I don't know. That's for the HVAC division to manage. The acoustical engineers, it was important to know that, because if you've got a flexible duct, maybe that is or isn't wrapped correctly, you could have some weak points in the acoustics. But again, that's outside of our product base, so we don't spend a lot of time in there. I'm not going to go into too much depth in it. And then we have the ceiling damper itself, which also is part of that that conversation for the acoustical engineer. So now we're going to get into the parts where we see a lot of variation, which is the bats and blankets. So you can see here glass fiber or mineral wool insulation bearing the UL classification mark on it. One thing to note is that insulation thickness and spacing may change the channel requirements. So it may change how your resilient products are attached or can be attached to your system. There are 6 variations to the insulation section, all the way from glass fiber, mineral wool, and then your sprayed in foam, and then also fiber sprayed insulation. So that'd be where they put a net up and spray in the cavities. Those are all part of that insulation section. So line 6 is the resilient channel. So line 6 we've broken into a few sections in here. So part A of line 6 is the resilient channel itself. So a resilient channel, as listed in here, can be placed at 24 inches on center when there's no insulation in the cavity, and that's a single layer gypsum board. So that's great for spacing. It passes the fire test just fine, but from an acoustical standpoint, it's probably not the ideal system to build. So typically we like to see insulation in these cavities. So now you're looking at a 16 inch on center max spacing when you add insulation, and that insulation is limited to 3.5 inches and has to be placed or pinned or stapled to the top side of the system. So it'd be stapled to the underside of the plywood or held in with, let's say, lightning rods or another manner that's approved by UL. So that gets us a minimum amount of insulation, gets us a good start into the noise control section of this system. Now, when you want to increase that insulation and or move that same 3.5 inches from the top side of the assembly down to the bottom side and drape it over the back of the channels, now your channels have to go to 12 inches on center. And what we see here is that increased channel spacing sometimes reduces the acoustical performance of the system. To what level is going to be determined on the set of test series that you've seen that give us some information on that. We don't have, there's no finite number that says if you go from 16 to 12, you lose 2 or gain 2 or whatever that number is. But acoustical engineers, be aware that sometimes if you want to fill that cavity with insulation, or if you want to put R19 in, or a thicker amount of insulation, something more than 3.5 inches, and you want to move it down from that top side, you have to change that spacing on that channel. Now, I'm going to cover something here. This is for this one assembly. Not all assemblies are going to have these same restrictions, but this is pretty similar with most open web trusses and a lot of other floor systems. So I think most of the I-joists will follow a similar line. Each assembly is going to have its own criteria, but this happens to be the criteria for this one assembly. So now we get into the RISC products or PAC products. And these are going to be your clips and your springs and your RC boost. So the PAC RC boost follows the same guideline as line 6, which states that you can go 24 on center with no insulation, 16 on center with 3.5 inches pinned to the top. And any insulation laid over the back or more than 3.5 inches, you have to change that channel to 12 inches on center. So again, acoustically, we're going to see some changes there, and we just need to be aware of those requirements so that during the design phase, we aren't designing systems that are not unbuildable, but maybe not buildable in the intent that they were originally set up acoustically. Then we have item 6A, I, and J, which is our RISC 1, RISC V, RISC SIX, RISC SI1 Ultra, and RISC 1.5 CRC. So all of those products follow the same general guide, which means your channel is spaced at 24 inches on center. If you have no insulation, 16 inches on center with 3.5 inches pinned to the top side, and 12 inches on center. You can pretty much do whatever you want, except for fiber sprayed. Fiber sprayed, you have to add a second layer of gypsum board. And I'm sure that just has to do with the heat retention of the full fill cavity. With fiber sprayed, it holds the heat into the gypsum board, forces it to fail sooner. So we add a second layer to help improve that gypsum board's performance from the fire life and safety standpoint, which also happens to improve our acoustical performance. So those aren't bad things, having a second layer gypsum board, but just be aware during the design phase that if you design it with 2 layers and then somewhere down the road, someone VEs the project and removes a layer of gypsum board because they take a glance at the UL design and see that it passes, but yet they don't change the insulation, they don't have a conflict with their UL listing. And it really doesn't meet the 1-hour fire rating that they originally had it designed to. So, yeah, Mike.
Yeah, I was just going to jump in. You mentioned the 1.5 the RISC 1.5 CRC. That's not included in here. It's the RISC SI CRC Easy, which is the spring that you see here on the right that works with cold roll channel and hat channel.
Yeah, so I saw the clamp there and instantly went to the 1.5 cold roll channel. So yeah, thank you for correcting that. So I was going to get to that product again specifically because the one thing that we'll see on some of these assemblies is when you change the channel spacing, your support for that channel also has to change with it. So when you go from 16 on center to 12 on center because you want to fill this cavity with insulation, the RISC SI-CRC Easy is a great alternative here because those clips are going to stay at 4 foot on center. So the clip distance between the clips doesn't have to change. All we change is the frequency of the channel. So in that system, your cold roll channel still runs at 4 foot on center and your clips are still at 4x4 on center. All we're doing is adding furring channels in between them. So from a cost conversion standpoint, that spring becomes pretty efficient versus the SI1 Ultra, which is going to be at 12x48 on center. So you're going to have a product with similar cost that's almost 3 to 4 times more frequent. I'm not trying to undersell my products. There's definitely systems where the SI1 Ultra is the right product. But if you have that depth to give up, the SI-CRC Easy may be a good alternative for you to give you some more flexibility in that system without making drastic changes in some of the other products that go into that system. Now we're going to get into some of the outliers, and we talked a little bit on walls about some of the other products aren't really unequal, even though they're similar in nature. They apply to the same areas. They do the same things acoustically. But from a fire life and safety standpoint, there are definitely some variations that can cause issues down the road or initially during pre-construction or construction phases of the project. So we're gonna point out the line items and the item number. We're not going to brand anything here. So we've got 6A through Q. So these are all of the clip and springs that are involved with this particular system. So you can see here item 6C specifically doesn't state that it can be placed at 24 inches on center because its max spacing is 16 on center. Now, it doesn't also state that you can have insulation in this cavity. We can make a general assumption that the rule of the system says if you're 16 on center, you can have insulation on the top side. This doesn't specifically state that. So what we've come up with is that it's really up to the building official on how they read the UL design and how they interpret it. So if you're reading it by the letter, 16 on center is still with no insulation. You can only have insulation in the system when you put the channels at 12 inches on center. And with that being said, then you have to go to, well, this particular 6C has to have 2 layers of 5/8 gypsum board anyway. And its maximum insulation can be 3.5 inches. So there's a lot of handicaps that come with this one line item, that some of this can still be, is to be determined, but some of it is already predetermined where you can't go 2 foot on center. You have to go at 16 or 12. And if you add insulation, it looks like you have to be at 12 on center and 2 layers of gypsum board. So acoustically, we're okay with the 2 layers of gypsum board. That's great. More mass is always good for noise control. Insulation is always good for noise control. But being handicapped or stuck with 3.5 inches and 12 inches on center, we haven't tested 12 inches on center, I don't think, in an acoustical scenario. And I know that I don't think anyone else has either. I may be wrong with that, but from my experience, I haven't seen a test with the channel and the clips at 12 inches on center. So that one product has these items that we need to be aware of and pay attention to during pre-construction and construction phases. Then we get into 6D. 6D has similar restrictions, where it's has the way it's written states the same thing: channel at 16 on center maximum. It doesn't say you can put it at 2 foot on center. And then it says the clips are at 4 foot on center along that 16 inch on center spacing. The reason I pointed out 48 inches on this one is because you can see here when the channel goes to 12 inches on center, because you want to add insulation to the cavity, the clips also have to be reduced to 24 on center. So now you've got this product that we thought was going to be at 2 foot by 4 foot on center. In a worst case scenario, you're 16 by 48. Now it looks like you're 12 by 24. So from a cost standpoint, this product became very expensive and probably not acoustically tested at that range, at 12 by 24 on center. So again, another hurdle with this one line item. And now this is all in just this assembly. Not every assembly is going to have these handicaps or these restrictions, but this one assembly, which is an Open Web Truss, which L521 is another common assembly, has similar text in it. So it's not just this one assembly, I guess is what I'm getting. So I kind of jumped the gun here, but let's get back to 6E, which is another alternate clip product. And you've got channels maximum spacing at 16 on center with the clips at 48 inches on center. This has the same text as 6D, where it states that when you add insulation to the cavity, the clips go to 12 inches on center. It specifically says when insulation is draped over the back of the channel. But anyhow, when you add insulation, you have to reduce the clip spacing to 12 by 24 on center. Now this one, you can still have a single layer from an acoustical standpoint. We still want that second layer in, but from a fire life and safety standpoint, that is not the best scenario. And again, probably not ever tested at 12 by 24 on center. And we have pictures of the Risset clips here. None of these are PAC products, just so everyone, we can draw a line between these two and say the 3 on the left are not PAC products, even though there's a picture of PAC products on this page. So that's one thing that we these are the types of things that we can catch in the process. Mike and I have probably spent 5 hours going back and forth on how it's written and how it's interpreted and what let's call the spirit of the text is. At some point you have to, from a constructability standpoint, you have to think like the building official. What is the building official? What's their goal and how are they going to read this? Now that's not how UL has written it. There's an intent to how UL writes it. So I'm hoping to get further definition from our friends over at UL on exactly what these mean, but the way we're reading it and the way I was taught to read a UL fire resistant design is if it's not listed, you can't do it. And this specifically doesn't say 24 inches on center, no insulation, 16 if it's pinned to the top, 12 if you drape it over. It only says max spacing 16 on center. And then when you add insulation over the back of the channel, it's 12 inches on center. So just something from an acoustical standpoint, be very aware of these, and you can look up the UL design and see which products those are without a whole lot of effort. Get to that here in a little bit too. So that's the end of section 6. There's a lot of variations, a lot of things that happen in here. Part of it is because there's a lot of clips and channels and isolators that have been included in, or added into these systems over the last 20 years, mostly with the PAC products, but obviously with other products too. Oops, I did it again. So now we're into item 7, which is the gypsum board. Now, there's a lot of manufacturers involved in this one, which is part of the reason why we jump ship from L521 into L587. L587 has more variation when it comes to manufacturers that are listed in the system. And again, it's stuck with the Open Web Truss that we were looking for. So with this system, your gypsum board, I don't know if anyone remembers the walls, they have it in 48-inch wide and 54-inch wide. With this system, because it's a ceiling, there aren't too many 9-foot wide ceilings where you need a 6-inch extra width on your gypsum board. So these are going to be 4 foot wide by random length, 8s, 10s, 12s, even 14-foot long 5/8 gypsum board. Your screw spacing into your channel or into your frame is 12 inches on center when there's no insulation. When you add insulation, the screws have to reduce to 8-inch. There may be some play on acoustics there when you're screwing into RC channel. When you put more fasteners in, you are increasing the probability of a short circuit by increasing the number of isolators into that system. I may have said type X earlier. The gypsum boards that are listed in here are type C gypsum board. Ulix is the only one that is the, I guess, branded in here because that's USG's lightweight gypsum board. And I think it's the only lightweight that's listed in the system. So again, back to the screw spacing, you've got your screws at 12 on center with no insulation, 8 inches on center when you insulate the cavity, which again, may or may not cause some issues with RC channel. With the Risset clips and other spring isolators, you shouldn't have any issues because those screws are far enough away from structure that you're not going to see short circuits. You can see here item 6, A, B, C, C, F, G, H, I, J, K, L, M, and N all are installed with a minimum of 1 layer of 5/8 type C gypsum board, or item 6, C, and D, which we touched on earlier, needs 2 layers of 5/8 type C gypsum board to get that 1 hour fire rating. And again, there's 14 manufacturers involved in this system, which again is why we jumped over to this system, just to get more variation in it. And then the last 3 items are pretty simple. Line item 8 is your finish system. That's your mud and tape on your ceiling, and that's your texture, whatever you decide to do there. Your grill is going to line up with your damper. It says in accordance with the damper used. So your grill or your face on your cover on that vent is going to be based on the damper system. And again, acoustically, it's kind of outside of our circle. We don't spend a lot of time with HVAC, so that's going to be up to those HVAC manufacturers to provide you the acoustical ratings for those openings. And then wire mesh for 5A and 5B. 5A and 5B is that sprayed in fiber insulation, and they put the mesh up and they spray the insulation, and it holds it up so it doesn't fall out while they're in between insulation and gypsum board. So that's it for the assembly, and yeah, there was a lot of information there, really just on the insulation and channel sections. You can imagine when you add in the 27 options for the top side from an acoustical standpoint, how many other performance levels you can get out of that. Just based on mat, no mat, poured in place material directly on the plywood. Maybe a 1/2-inch mat, 1/4-inch mat, 3/8, 5/8, 3/4, 1.5-inch mat. There's all kinds of options there, and a lot of manufacturers that are involved there. So you're going to have to go to those manufacturers to find out what their systems add or don't add to that, the base acoustic system that's there. So, back to how do I find all this information out, and how do I apply it correctly? UL is a great source. They actually give you everything online. The most difficult part with UL is working through the system like we have just done there, determining which product is allowed to use, how much insulation, what the spacing is, how much gypsum board is needed, where can the insulation be placed within that cavity. So there's a lot of text to read and a lot of text to interpret. Another source is your ICC evaluation service. So those are provided from the manufacturer. So the good thing about the ICC evaluation service is that it does take in a fire test and a sound test and builds a system, a summary of the system, and then it states, it was this UL fire test or this fire test done at this lab on this day, and here's the test number. It doesn't necessarily have to be UL. And then it also puts together typically the acoustical design and or structural limitations of the system. So sometimes in an I-joist, it'll have the span indexes of the I-joist. Let's say that's just an example. Or in Open Web Trusses, it may also state the span indexes. So in that ICC evaluation service, there's a lot of ways it can be published. It can be published with a we met minimum. It can be published with the actual test report or actual acoustical number. They don't provide you the full acoustical test to verify that what is drawn and what is shown is exactly what was tested acoustically. And again, there's no source online or even in a book that says, here are all of the ICC evaluation reports or all the ESR reports that have ever been published. Go look at them and use them. So that's a one handicap with that system, is that it's only supplied by the manufacturers. Then you have the Gypsum Association Fire Resistance Sound Control Design Manual, which is a great place to, I would say, get started. I wouldn't say that's the beginning, middle, and end of your research when it comes to UL and acoustics, because the acoustics are published in ranges, and sometimes the acoustical report isn't exactly what the UL fire resistive design was designed to or what it was built to. Again, they're going to reference a UL design. And as we just went through, there's a lot of options in that UL design that may not line up with the acoustical test that was published against that system. So again, there's still more homework to do. I mean, it's a great place, like I said, to get started. But you definitely should see if you can get a copy of the acoustical test that they state in there, which you're going to have to get from the manufacturer if they exist or if they haven't lost the document or never published it to start with. And then you're going to have to go to UL and make sure that all of those things line up. So you're still not going specifically to one place to get all your answers. And then we have the manufacturers like us who are trying to put all of these three items really together for you and get you hopefully a more comprehensive version of one or all of these. So we're, and other manufacturers do similar things, normally aimed at an intent. Ours is multifaceted, where we're going to give you the ability to search based on acoustics. We're going to try and give you the ability to search on fire rating, and then we're also going to try and put those two together for you and let you predetermine what you want acoustically, and then we can go see if it's going to actually meet the UL fire resistive design based on the criteria. So how can PAC help? We talked about a little bit with giving you these options. Again, we have a wealth of knowledge in the construction industry, mostly also actually, over 40 years of real construction experience, swinging a hammer, running a screw gun, doing all of the dirty work out in the field that has given us the ability to design and build products with that in mind, not just a great engineered product, but also a product that's engineered correctly for fire life and safety, for sound, and for constructability. That's a big push for us, is to make sure that our products, when they go into the job, see similar results to the fire test and sound test that we've done. And that's just comes with the experience of being in the field and doing that. We have over 20 years of testing at UL, and also not at UL, but mostly at UL, and then also acoustically testing our products all around the world. We've tested not only in the States, but outside of the US and a few other places. So we've got a good wealth of knowledge. I think we've tested at almost every acoustic lab in the US. I'd have to go back and look, but we've hit most of them. And then we have our online fire and sound assembly databases. So that's our big push right now, is to give you the acoustical engineers, the architects, the builders, developers, our suppliers, everyone, the access that they need to get either their customers the answers they need, or to get themselves the right answers to be able to write the spec correctly on the first swing, so that the value engineering, when it comes back, either we know how to make sure that the product that they're trying to change is either a PAC product. Obviously, we want PAC to PAC. We don't want PAC to another brand, but at least make sure that we know what's being changed and how it's being changed. And it's something that we see quite often in the VE phase. of projects sometimes is that the products that are being substituted, even though they look on face as an equal or a similar, are not. And then another big push for us, especially now as we keep moving forward, and has been for quite some time now, is to acoustically test our fire rated systems. So when we go to the acoustic lab, we really try our hardest to test exactly what UL's letter of the law is, if you want to call it that. So if the spacing says you need to be 16 on center and the insulation has to be pinned to the top, then we will do that, because we want our acoustic test to line up with the fire life and safety designs to the best of their ability. Not all manufacturers do that, not all testing facilities. I mean, the acoustic labs don't talk to the fire labs, so there's no communication that says, well, you know, you shouldn't build it that way, you should build it this way. The reality is that the consumer is the person that guides those systems and those designs and that construction type. So if the consumer, the person that's paying for the test, doesn't have all of that information and doesn't know how to put those two together, you may have two entirely different systems that somewhere down the road they're going to try and put together. So for us at PAC, that's something that we want to do on the front end, is make sure that those systems line up and can be pushed forward smoothly throughout the construction phases. So here we've got our current fire rating selector, and this has all of our UL designs in it. It has limited filtering, but it does have a good, again, starting point, like we talked about with the Gypsum Association, where you can say, I want an I-joist or an open web truss. I want to use, I need it to be 1 hour fire rated, and I want to use 1 or 2 layers of gypsum board, and it's a ceiling, right? So what's going to happen here is it's going to filter down, and you'll be able to see, let's say it's L521 or L528 or L587, you'll be able to see all of the PAC products that you can use in that system. So that's based on the UL fire resistive design. It's not based on the acoustical test and the UL design. It's just based on fire rating itself. So we give you the links to go straight to the UL fire resistive design. We've got them on our site now. We update them, gosh, I'd say probably once every month or two, because UL is doing updates quite often. You can also link straight to the ul.com website and go there. But the reports are here, so you can start thumbing through and look at the products and see if there's any limitations on spacing, insulation placement, number of layers of gypsum board, all of those things, especially now that you kind of have an idea of what to look for. So one thing that we're doing is I'm getting ready. Well, I've been processing this for quite a while now. It's a new UL fire resistive design selector. It is much more in depth, and it's going to have those details that we just covered in it. So if there's a clip that has to have 2 layers of gypsum board, it'll be listed in here with 2 layers of gypsum board. If it a PAC product, it'll be listed with 2 layers of gypsum board. If it's a non-PAC product, we're not going to show you what it is. That's for you all. But we're going to list how all of the PAC products break out. So here I've taken L587. I've just shown RISC 1. Just the PAC products on here, I think, is 18 lines. So there's 18 options with just PAC products between no insulation, pinned to the top side, full cavity of insulation laid over the furring channel, and then fiber sprayed on here. So those are the 4 options in this system, which again line up with our RISC 1, RISC SIX, RISC SI1 Ultra. All of our clips really follow the same guideline. So you can see here, as you scroll across, this is a long spreadsheet. So we've broken it down on the left-hand side and allows you to search, and then we've also given you this detail page. So what you can do, and it's not the GUI interface isn't set up yet, so it's very bare bones. But when you click on one of your lines, it'll give you the summary of that line, including the links to the UL design, link to an acoustical test report, and the link to the acoustical summary page for the builders, developers, architects. They don't really need the whole report typically, but the acoustical engineers need access to all that. Now those test reports, the summary pages are through your login. So if you don't have a login, when you click on that, you'll get routed to a please log in page or a register page. But each of these are going to have a different set of information on them. So I think I clicked on the second one. No, that's the first one again. So that's 24 inches on center for the frame space. No, it is the second one. 16-inch on center for the channel spacing. RISC 1 clips. It's a rubber isolator, not a spring isolator. It's 1 hour fire rated. and the insulation's at the top. And if I scroll down a little more, which I don't think I do, it states that there's a single layer of gypsum board. There we go, single layer gypsum board. And then again, there's the link to the UL PDF and then a link to the acoustical information. So these summaries give you a way to maybe put it all on one screen and get a quicker drill down of what the system is or isn't. So my goal is to have all of our UL assemblies in here. My guess is it'll probably be, I'm hoping for midsummer, but it's looking like it may squeak out a little longer than that, only because the more I get into it, the more we run into these terminology questions. And I want to make sure that I have a 100% correct understanding of UL's intent of the word, and that it's black and white so that we aren't muddling any waters down the road. So we've still also got our standard assembly selectors. The standard assembly selectors are PAC assembly selectors, which are separated for walls and ceilings. And you can see here on the left-hand side, you can click your fire rating. So if you want 1 hour, 2 hour, 3 hour, you can select wood, steel, concrete, CMU, whatever your construction type is. And I think in here we just have concrete, steel, and wood. Yep. You can select the number of layers of gypsum board. You can also just sort this by STC. If you know you need an STC 55 wall, just put in 55 as a minimum, and it'll give you everything. And then you can sort after that. So you can go back up to the top and sort. So it's not a linear sort. You can randomly sort these systems based on the criteria that you have and that you need for your assembly. And that's it. I feel like I've been talking forever, but it's only been 40 minutes. So we again, we really appreciate everyone taking the time to visit us for this. We hope the information is enlightening, if nothing else, at least for the acoustical professionals here, and maybe a few architects and a few people that aren't as well versed in the way UL is written and the way that it's interpreted. So I think I'm going to back out here. I have a cough coming. I apologize. I'm going to have to mute myself. I've been fighting a cold off, and I'll let Mike take over. Thank you again.
Yeah, sure. Thanks, Mike. So yeah, if anybody's got any questions, you can unmute yourself. I see Norl, you've got your hand raised. So go ahead if you can unmute yourself. Go ahead, and if not, we'll allow everybody to unmute. Mike, you might have to do that. Oh, it looks like I can allow it. Norl, I think you can unmute now. Yeah.
Yep, sorry, I did it too.
Yeah, I was having trouble finding the microphone there. I guess there are just 3 things that occurred to me as thoughts that might be helpful to somebody who went through all this. One, there are some situations where you may be required to have a choice between either filling the cavity full with insulation with absorbent fiberglass or mineral wool, or putting sprinklers in it. And the architect may want and builder may want to fill the cavity instead of putting the sprinklers in. And find there are assemblies out there that allow that.
Yes, sir.
They typically, I think, require 2 layers of gypsum. So when I had a case where that was the plan, the architect had a assembly they planned to use and had a particular clip they wanted to use. Come to find out at the last minute that the manufacturer, whatever documentation it is that was not in the UL listing for that assembly, specifically said the absorber could not be more than 6 inches thick. And they were in trouble.
Yep. Yeah, and
manufacturer came back and said, "We really will work and everything. We just put that in there."
Like acoustics, maybe I would say, yeah, it'll be fine. But fire life safety is a little different. I don't want to take any risks on that one.
The acoustics, I would have given in on it and everything, but the nobody would accept the manufacturer saying we should have put it in there to allow it full. Well, that's not what you did. Okay.
Shoulda, woulda, coulda.
Sure. Yeah. So on that note, Norl, I stated in here, I think at least once or twice, these are just limitations on this one assembly.
Yeah, I know.
And you're right, there are other assemblies that are going to have a lot of options.
Right.
You know, there's, gosh, I don't know, they're into the M's now, so they've gone all through L500. And so that they're into the M's now. I mean, eventually they'll be into another letter. So
Yeah.
they're growing still.
Second point, you showed the flex duct ventilation duct there.
Mhm.
And that can be an issue, especially in cases where you spend a lot of money on your ceiling and spend less money on your floor, and you have some impact sound on the floor in that cavity, and that flex duct is basically a window.
Yes, sir.
Yeah. Yep. So Neural, as Mike was going through this and I was kind of reviewing the PowerPoint presentation that he had put together, I saw the air duct and I was like, wait a minute, is it only flexible duct? Oh, wait, can you hear me? My screen just froze.
Yeah, we can hear you.
Hear you.
Okay. I'll keep going. I might get kicked out again. But so I went back and I looked at the UL assembly, and it does say explicitly flexible air duct installed in accordance with the instruction provided by the duct manufacturer. The air duct may be connected with a steel duct elbow, but it does not, as far as I read it, provide any provisions for, actual steel duct, whether rectangular or round. Now, I'm sure you could find some other UL assembly that's similar that maybe does allow that, or would have different restrictions. But yeah, that's an interesting thing to look at, and it's all those little details and nuances that as I've dug into this more and more, my head starts spinning, and I realize how many things there are to try and keep track of.
Yeah, and you can help yourself, of course, by shifting your emphasis to put more emphasis on the floor and less on the ceiling, so you don't have so much, say, tap in the cavity. And also by being careful about where you put those things.
Yeah.
If you can get them out of the beaten path where nobody's walking over them, you're in better shape. But sometimes they want to put them right in a door or something, where you know it's a major traffic pattern.
Right. Yeah. That's one of the great items or line items that you could place against or argue with an open web truss versus, let's say, an I-joist or solid timber, is that it allows you just to move that duct over another bay and get it out of the way.
Last thing, as far as I know, most all these assemblies require Type C gypsum on the ceiling.
Yes, sir.
I do see people out there using Type X.
Yeah.
Yep. There are some exceptions to that. I think like within the ESR report for the I-joists and wire housers, ESR 1153, it does allow Type X in there, but that's a 2-layer. Pretty much all of the options in there require 2 layers, which is pretty common with wood I-joists. But yeah, most of the time it is Type C, Neural, not Type X, and that's something to keep in mind, and that's something that we pay attention to in our testing too. Like Mike said, we try and do our acoustical testing to match the fire rated designs. So Elzo has hammered into me that we only ever use Type C on a floor ceiling test. On walls, we will test with both Type C or Type X depending on the situation, because usually either of those can be used there, obviously depending on the specific assembly you're working with.
Elzo, do you want to chime in on that Type C versus Type X conversation?
I sure will, but I'd first like to start by thanking Neural. He's been a fantastic contributor to each and every one of our conversations or webinars. Neural is a wealth of information and a tremendous experience. Almost feel like we need to send him a royalty check. But as far as Type X versus Type C, getting away from the royalty check conversation, Type X is the original fire-rated gypsum board. Type C is a 3rd generation gypsum board, fire-resistant gypsum board. Type X has an ASTM standard, so functionally all Type X's are similar and tested to a minimum standard. Type C, however, has never been able to agree on a minimum standard for the fire test. So Type C is still proprietary and exclusive design. And a couple of manufacturers now have kind of tuned in, and they manufacture their Type C board, but they label it with a Type X. So some of the ceiling board that we're running into now, to get away from that ASTM argument going on between the manufacturers, are actually making a high performance type C with a type X label so that it can be generically used, which Norrell had commented in prior sessions about proprietary brands. And hopefully this transition of opening the type C into the type X world will help eliminate some of that challenge that Norrell has faced in the past and other acoustical engineers. I really appreciate everybody working so hard to put these things together. You guys did a grand job. Thank you very much, and turn it back over to you.
Did you have anything else, Norrell, you wanted to talk about?
No.
Okay. So yeah, to summarize the length of this, we only really focused on section 5 and 6 of this assembly. There are, I don't know, section 7, the gypsum board itself is a paragraph that's just short of a novel in here. So the if you were to print L587, I think it's 13 pages of text. So there's a lot to do to go through in these systems, and not all systems are this big, but not all systems are small. So there's it would behoove everyone here, if you have the opportunity to pick one that's easy and start with that and work your way up to the more difficult systems, and easy being probably the shortest one you can find. But hopefully we've brought some light to the UL design and the variances between fire rating and acoustics throughout this series. And like we stated before, I think Mike and I have agreed we're probably going to do a 4th webinar based on some specific criteria for maybe wall and ceiling intersections or wall intersections, and then maybe some general provision information that we weren't able to cover in this. So again, thank you everyone. And like Mike has stated before, we'll have this up on our website and on YouTube, and everyone that's here should get a link in the next day or two to those videos so they can share them, do whatever they want to do with them, re-listen to them, pull up a UL design and try and read with us. That would be a great exercise in patience. Let's put it that way. So,
exercise in patience. Yeah, if you're having trouble falling asleep, go ahead and try and read through. Yeah, do we have any other questions? Mike, maybe you already asked. I got booted out of Teams again, but yeah, if anybody's got any other questions, feel free to just unmute yourself and ask. We can hang out for a few more minutes, but otherwise, yeah, thanks everybody for joining us, and we really appreciate you taking the time.
Hey, Mike, I got one. This is Jerry Lawley. I got one question. On your ratings, fire ratings, you're talking about 1 hour. Do you have anything on ratings that are more than 1 hour?
Yeah, we do. We have, I mean, on walls, there's a pretty significant, range there, but on floor ceiling assemblies, we do as well. Also, I see you've got your hand. Feel free to just unmute and jump in. We do. Mike, what was the assembly that we were just looking at? It was a 2-hour rated, it was an open web truss. So Jerry, one of the things on 2-hour floor ceiling assemblies that usually comes up that you see is there will be a requirement to put gypsum board directly attached to the bottom of your structural members. And then you might have 1, 2, or even 3. There's an assembly that I'm working on for a project right now that's got 3 layers of gypsum board attached directly to the bottom of I think it's solid wood joist in this instance. And then there's usually either resilient channel or hat channel to create a small air cavity, and then an additional layer or layers of gypsum board there. So you get both gypsum board hard attached to your structure, which is not good acoustically, and then you also get this very small air cavity in this sort of triple leaf thing, which is also not good acoustically. The one thing that we did see, Mike, is that you sharing your screen? Oh, you're muted. I see your Teams, but not maybe the UL assembly that you're looking to share.
Oh, that's why I moved it out of the page. There we go. Let's try that. I moved it off of the screen. My apologies. So I pulled up a 2-hour fire rated solid timber system, and I pulled that off of our right off of our product fire rating selector. I just put in 2 hours, scroll down to I saw a solid timber right here.
Yeah. So there was one that we were just looking at where instead of having a continuous gypsum board layer that's attached directly to the structure, it actually just required a 6-inch wide rip of gypsum board to be run parallel to the structural members. And then you had your additional sort of ceiling layers and things like that down below it. Right. And so that actually kept exposed. Yeah, there you go. That the large cavity there within the trusses, which is from an acoustical standpoint, way better than the typical design. So that's something to kind of look for. And yeah, you can go look into our fire design selector. You can find ones that are 2-hour rated. And yeah, try and find. But there are there can be some really big differences between the acoustical performance in those systems. So kind of hunting around for once. And maybe that's something that we can figure out how to include in our more detailed fire design selectors. I'm not sure how we'd work that in, but probably something we should consider. Sure. Elzo, I imagine you have things to add.
Yeah, that particular design is a USG proprietary design, okay. Which is also the owner of the ULEX, which you referred to earlier in the conversation. Mm-hmm. And the ULEX design uses a cavity fill bat insulation, but under the provisions of the National Fire Sprinkler Code, if you have a cavity, let's say an 18-inch deep truss, if you fill that cavity, you don't have to sprinkle it. But it also has a provision in that same NFPA 13 that if you create a cavity less than 8 inches, that you don't have to sprinkle it. So in an 18-inch deep truss, if you threw in a 12-inch bat, from a omission of the fire sprinkler portion, that you also have the latitude. So if you fill the cavity or create a cavity of less than 8 inches, you can avoid sprinkling the hidden cavity in that fill. So that's all I wanted to throw in, and thank you.
Jerry, did that answer your question or answer it?
Yeah, I just mostly wanted to know if there was something other than 1 hour. I think I had a project where they required 90 minutes of fire rating, which is a different thing. So that's fine. That's all I wanted to know.
Yeah, we've got them. In short, yes, we've got them. Yeah, thanks, Jerry. All right. Well, if that's it, I think we'll go ahead and wrap it up. If anybody thinks of other questions or has anything else, feel free to reach out to us, shoot us an email, give us a phone call. And we will be posting soon what our next webinar will be as soon as we figure out what it will be. We've been working on this and haven't really planned what the next one will be, but I think we'll maybe take a break from fire and get back into some more acoustic specific and maybe some product specific or testing specific presentations. So thanks again, everybody, and have a great day.
Thank you. Take care.